Our lesson on 9.5 is going to have us add and subtract rational expressions. Now, before we do this with Algebra 2, I want you to go back to 5th grade with me and think about how you added and subtracted fractions. So if we had the fraction 3/5 and we have to add to that, let's see, 7/10. The only way you could add fractions is if they had common denominators. So your 5th grade teacher would ask you, what is going to be your common denominator for a 5 and a 10? And you would realize that the answer to that question would be a 10. So kind of half good news, the first fraction does not have that denominator, but the second fraction does. So you'd have to change the first fraction to be a denominator of 10 by multiplying both the numerator and the denominator by a 2. The reason you had to do both top and bottom is because 2 over 2 is really equivalent to a 1. So this becomes 6/10 plus 7/10, and that would give us 13/10. So we're going to use the same concepts here in 9.5. So the first two examples here already have common denominators. So when we add our common denominator, or when we add our fractions, we add the numerators, that would be a 9, over our common denominator, you just keep that. Now we have to think about algebra and how you can simplify. The 9 and the 3 can both simplify by dividing both of them by a 3. So this becomes a 3 over a 1x, which is just 3 over x. Similarly on number 2, you already have common denominators, so if we just combine the numerators and rewrite it over the common denominator. Now technically this is the final answer, but we can have a factor of 2 that you can take out. And I would prefer you to factor everything that you possibly can as you do these problems. Alright, number 3. It looks like they might have common denominators if we were to do something to the second denominator. He seems a little backwards. So the trick I'm going to use is I'm going to factor out a negative, and I'm actually going to bring the negative right here. And when I factor out a negative, this becomes x squared minus 9. So now what we have is 2x plus 11, and then this subtraction sign is actually going to be distributed to the entire numerator for the second fraction. So it becomes a minus 2, but then a plus x. And then our denominator is x squared minus 9, which I'm going to go ahead and factor into x plus 3 and x minus 3. So if I combine my like terms, let's see, I've got 3x, and then plus 11 minus 2 is a plus 9, over x plus 3x minus 3. And then I notice that my numerator is a common factor of 3 that I could take out. And good thing we did, because now the x plus 3's are going to cancel out. So if we cross off the x plus 3's, you end up with the answer of 3 over x minus 3. It's a lot of work for what looked like a little problem at the beginning. Okay, on number 4, we do not have common denominators. So what I want you to think about is what is going to be your common denominator. So this first fraction requires an x minus 5. Remember, that's one whole term. The next fraction requires an x plus 2. So your common denominator is going to need both an x minus 5 and an x plus 2. So when I look at my first fraction, he's got the x minus 5, but he's going to need to be multiplied by an x plus 2 on top and bottom to make this work. And then for my second fraction, he's got the x plus 2, but he's going to need the x minus 5. Okay. So for my first fraction, 2x times x plus 2 gives you 2x squared plus 4x. And then careful, this is a negative 4 being distributed into the x minus 5, so that is a minus 4x and then a plus 20. Now you want to collect your like terms. We end up with a 2x squared plus 20 over x minus 5 times x plus 2. Now technically this won't reduce anymore, but just for good habit, I would like you to factor out the common 2, because sometimes when you take out that common term it will factor, and then like on the last problem we saw something might cancel. Okay, so this is a great answer. This is the way I like to see it on your homework. Fully factored, combined, everything reduced as much as you can. Now number 5, before I start thinking about what my least common denominator is, I think we need to factor that second denominator a little bit so we can see what's really going on. So there's a common factor of 2x that we could take out of it. So if I took out a 2x, you're left with 2x minus 1. So when I think about my common denominator, and I'm going to write it over here, this fraction needs a 6x squared, and this fraction needs a 2x and a 2x minus 1. Well, the 2x and the 6x squared, the 2x is actually a factor of 6x squared. So if I just go ahead and put down 6x squared, by default, I'm kind of already including the 2x. But I also need the quantity 2x minus 1. So let's look at the first fraction. He's got the 6x squared, but he still needs the 2x minus 1. And remember, top and bottom. So the second fraction, he's got the 2x minus 1, and he's got some of the 6x squared. He's got 2 x's. So he's going to require a 3 and another x to make that a 6x squared. So when I go ahead and simplify the numerators, 2x minus 1 times the 5 gives us 10x minus 5, and then x times 3x gives us 3x squared. Now that's a quadratic, and I want to rewrite it in the correct order so I can kind of think about this. Let's see. And if it does factor, it's not a very pretty one. But here's what I would say. If I look at my denominator, there's no way I can factor this and get either one of these factors to cancel out with it. So I could try factoring it for a little while, and I would encourage you to do so, but it's actually not going to factor, and even if it did factor, neither of these would be a factor, so nothing would cancel. Okay, similarly on number 6, I think we need to factor the denominators a little bit so that we can see what's really going on. So x squared plus 4x plus 4 is really an x plus 2 times an x plus 2. And x squared minus 4 is really an x plus 2 and an x minus 2. So our common denominator, I'm going to kind of look at this as a list. I need an x plus 2 and then another x plus 2 because of that first fraction. He needs 2 of them. Now when I look at the second fraction, he also needs an x plus 2, but it's already included in me getting the common denominator from the first part. The only thing that's not in my list yet is the x minus 2. So if I look at my first fraction, he has everything except for the x minus 2. Now be careful, when we multiply this together, this becomes a FOIL problem up top. And then for my second fraction, he's got one of the x plus 2's, he's got the x minus 2, so it looks like he needs another x plus 2 to get to this common denominator. So if I go ahead and FOIL out the first numerator, I've got x squared, and then let's see, x minus 2x is a minus x, minus 2. And then be careful here, this is a negative 2 that you're distributing. So that becomes a negative 2x minus 4. Looks like we've got a bit of a quadratic situation again, so we need to simplify. X squared minus 3x minus 6. And then x plus 2. If you wanted to write x plus 2 squared like this, you could, instead of writing it twice. And then we do have a quadratic in the numerator, but nothing's going to factor because you can't multiply to a 6 and add to a 3. So we're done. Okay, number 7, rewrite that first denominator as his factor. So he's really an x plus 3 and an x minus 3. So my common denominator, let's look at this. We need an x plus 3. First fraction also needs an x minus 3. And then the next fraction agrees that we need an x minus 3, but good news, he's already included because of the first fraction. So I kind of over-anticipated my fraction bar there. Great news, the first fraction already has the common denominator. So let's look at the next fraction. He has the x minus 3. All he's missing is the x plus 3. So our first numerator is just 6x plus 1, but our next numerator, when I multiply the 4 through, I get plus 4x plus 12. Let's collect our like terms. You're going to have 10x plus 13. And there's no common terms there to factor out, so I think once we write our denominator, we are done. common mistake on these problems is sometimes students overthink the denominator, and they'll find a common denominator, but maybe not the least common denominator. It's not the end of the world if you do that. All that's going to happen is when you get to the end of the problem, you're going to have too many factors that are common, so when you do some reducing, you'll be able to cancel out some of the factors, and you'll eventually get down to the right answer, but your math won't be very nice, so you want to make sure you're picking the least common denominator. Okay, this first fraction, if I factor it out, his denominator is really a times a minus 2. And this next fraction, his denominator is really a plus 2, a minus 2. So when I think about my common denominator and what I need, the first fraction needs an a and an a minus 2. The next fraction needs an a plus 2, and then we've already got the a minus 2 in the list. So who am I missing in the first fraction? I need an a plus 2. And then in the second fraction, I just need a little a. And that's a 10. I kind of wrote over it, but 10 times a plus 2 will give us 10a plus 20. And then minus 5 times a would be minus 5a. There is some simplifying we can do here. Let's see, 5a plus 20 over a times a minus 2a plus 2. Now technically this is the right answer, but for good habit, there's a common factor of 5 that you can take out. Nothing cancels, but like I said, it's a great habit to always factor everything before you end the problem, because once in a while you'll have a factor kind of snuck in there that needs to cancel. Okay, number 9, let's factor this denominator into his parts. So we have, I think that'll be a minus 4, and a plus 1. And then this factor right here, let's see, I should have looked before I crossed it off. It will become an, why am I writing A's? Hello, Abruzzo, that's an X. Really, it's too early. Alright, x minus 4, x plus 1. Okay, this becomes x, let's see, minus 2x plus 1. So hopefully you're pretty good at factoring at this point in your life. Otherwise it'll be pretty tough to do this lesson. So let's look at our list. We need an x minus 4, we need an x plus 1, and then this fraction agrees with the x plus 1, but he also needs an x minus 2. So this first fraction is only missing the x minus 2. And this next fraction, let's see, he's missing the x minus 4. So when I simplify x minus 2 times 5, you get 5x minus 10. And then careful, this is a negative 3 that we're distributing, so that's a negative 3x and then a plus 12. So we end up with, let's see, 2x plus 2. Oh, this is going to have something kind of interesting happen. And then x minus 4, x plus 1, x minus 2. Now the 2x plus 2 in the numerator can have a 2 taken out of it, and it's 2 times x plus 1. Now you should notice that the x plus 1s are going to cancel out, so our final answer is 2 over x minus 4 and then x minus 2. So sometimes they're a little more involved than what you would hope. Okay, these are complex fractions, and the reason they're complex is because it's a fraction inside of another fraction. So the first thing I would like you to do is, instead of having it as a vertical division problem, let's rewrite it as a horizontal division problem. So the first one, I'm going to write it down here, is 3, I'm going to write it as 3 over 1, plus 2 over x, and we're going to divide it by 4, which I'm going to write as 4 over 1, minus 3 over x. Now before we talk about how to divide fractions again, let's talk about how to get these common denominators, because I don't want to have a fraction within a fraction. This is gross. So our common denominator for this first problem would be an x. So the good news is the second part of the fraction already has the x denominator. If I were to combine these together, I would have 3x plus 2, and then over the common denominator of x. The common denominator in the next fraction also happens to be an x, which the second part already has. So that becomes a 4x minus a 3 over that common denominator of x. Now think back to our previous lesson. When you divide fractions, what you do is you keep the first fraction how it was, but then you're going to multiply by the reciprocal of the last fraction. And this works out great because the x's are going to cancel out, and your final answer is 3x plus 2 over 4x minus 3. So they look really gross at first, but they're not that bad. Number 10, let's see here. I'm going to rewrite it horizontally, so x plus 1 over 2. Oops. And then I'm going to write the 4 as a 4 over 1, divided by 6 over x. Well, good news, that last part of the problem is going to be really easy because it's just a fraction. Our common denominator for this first part of the fraction, though, is going to be a 2, so I'm going to have to multiply top and bottom here by a 2. And that's going to give me, let's see, x plus 1 plus, this will become an 8 right here. So x plus 1 plus 8 is really x plus 9 over 2. And then instead of divided by 6 over x, I'm going to say multiply by x over 6. Well, this isn't very exciting at all. There's really nothing that's going to happen here. I'm going to leave it as x times x plus 9. I'm not going to bother distributing it in and multiplying because I want to keep things factored, over 12. Lovely. And you'll kind of notice the original problem and our final answer really don't look anything alike, and that sometimes will happen. Okay, 11's kind of interesting because it looks more complicated than the last couple, but we can handle this. Now, I'm thinking it's pretty good news. The first fraction is already combined into one fraction. So he is just 2 over x plus 2. But we're going to have to divide him, and this one's going to take a little bit of work, by this fraction. But I can't divide a fraction by a fraction. I'm going to have to get common denominators. So if I think about what the common denominator for this set of fractions is going to be, we're going to need an x plus 2, and we're also going to need an x. So the first guy just needs an x, and then the next guy needs an x plus 2. So our first fraction stays as 2 over x plus 2. I'm going to keep it as a division problem for now, but if I kind of try to simplify this, this becomes an x plus, and then 2 times x plus 2 is 2x plus 4. So collecting my like terms in the numerator, we have 3x plus 4. And then don't forget our common denominator for that next set was x times x plus 2. Okay, now it would be a good time to rewrite this as a multiplication problem. So the first fraction stays as 2 over x plus 2, but now it's going to multiply by x times x plus 2 over 3x plus 4. And you're going to notice that the x plus 2's are going to cancel, leaving us with 2x in the numerator and a 3x plus 4 in the denominator. Okay. But, oh, that's fun. Okay. This one will be a little bit of a challenge because not only are they not like denominators, they need a little bit of factoring and alright, good times. Okay, let's start with the first part of the fraction, 1 over x to the third plus 64. That is one of the cubic patterns, so even though I don't have to do anything to combine like terms, or to get common denominators, I am going to go ahead and factor it. So it factors into x plus 4, x squared minus 4x plus 16. Okay, so that's the first fraction. We're going to divide it by, yikes. Alright, I'm going to write this horizontally, and as I rewrite it, I'm going to go ahead and factor the original denominators. So x plus 4 times x minus 4 minus, I can take out a 3x, and I'll be left with x plus 4. Okay, try to think ahead with your common denominators. What are we going to need? So this guy has an x plus 4, x minus 4. This guy has an x plus 4. Something that this one needs that this one has, I see, is a 3x. And then vice versa, this one needs something he has, which is an x minus 4. Okay, that wasn't as bad as I thought. Still got a lot of work though. So I'm going to kind of cheat, and I'm going to write above here, 3x times 5 is really a 15x. And careful, you're distributing a negative 2 into this, so that becomes a negative 2x plus 8 in my numerator. And then our denominator, of course, is what we have written. So, because I'm tired, I'm going to kind of skip to the last step, second to last step. I'm going to rewrite it as our multiplication problem. Oh, long lesson. So we're going to multiply by this reciprocal. So the 3x, the x plus 4, and the x minus 4 go up top. And then that'll become a 13x plus 8 on the bottom. So I'm hoping something cancels after all this. Looks like the x plus 4 is gone. And that's about it. So up top we still have a 3x, and we still have an x minus 4. And then on the bottom, really gross, I'm going to write the binomial first. We have a 13x plus 8. Yikes. And an x squared minus 4x plus 16. Gross, 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 gross. But you know what? Sometimes that happens in algebra. So that is lesson 9.5. We're going to stay on this for a couple days because it's kind of hard.